Hello guys, welcome in today's video, and now we are going to cover one of the most important topic from machine learning, that is ensemble methods. Ensemble methods are a powerful approach in machine learning that combines the predictions of multiple models to achieve better performance than any single model could alone. The core idea is to leverage the strength of diverse models to overcome individual weaknesses and reduce the overall prediction error. Now, there are mainly three key concepts which helps you to understand the overall concept of ensemble methods. Number 1. Multiple models. Instead of relying on a single model, ensemble methods train a collection of models on the same dataset. Number 2. Diversity. The base learners are trained in a way that encourages them to have different strengths and weaknesses, reducing the risk of overfitting to the training data. Number 3. Aggregation. The predictions from the base learners are combined using a voting or averaging scheme to produce the final prediction. This aggregation helps to mitigate the errors of individual models. Now, let's talk about the common types of ensemble methods. Number 1. Bagging or bootstrap aggregation. It creates multiple base learners by training them on different bootstrap samples. Each base learner is trained independently, leading to diversity in their predictions. The final prediction is made by averaging the predictions of all base learners. For example, random forest is a popular bagging ensemble that use decision trees as base learners. Number 2. Boosting. It trains base learners sequentially, where each learner focuses on correcting the errors of its predecessors. The first base learners is trained on the original dataset. Subsequent learners are trained on data where the weights of misclassified instances are increased, forcing the model to focus on harder to learn examples. The final prediction is made by weighting average of the predictions from all the base learners, with higher weights given to more accurate results. Example: gradient boosting machine or GBM is a widely used boosting ensemble. Number 3. Stacking trains a meta-learners on the top of a set of base learners. The base learners are trained on the original dataset. The meta-learners is trained on the predictions of the base learners as its input features. The final prediction is made by the meta-learners. For example, stacking can combine different types of models such as logistic regression as the meta-learner with decision tree and support vector machine as base learners. Benefits of ensemble methods. Improved accuracy. By combining diverse models, ensemble methods often achieve better prediction accuracy than any single model. Reduced variance. Averaging or voting across multiple models helps to reduce the variance of the predictions, leading to more stable results. Overfitting reduction. The diversity of base learners helps to prevent overfitting to the training data. Disadvantages. Increased training time and computational cost can be more complex to interpret than individual models. Now, let's consider an example of image classification which uses ensemble methods. Imagine you want to build a model to classify images as cats or dogs. You could train a single decision tree model, but it might overfit to the training data or be sensitive to noise. Create a random forest ensemble by training many decision trees on different bootstrapping samples. The averaging of their predictions would likely lead to more accurate and robust classification. Alternately, you could use a boosting ensemble like XGBoot, where each tree focuses on correction the errors of the previous ones, potentially achieving even higher accuracy. By effectively leveraging ensemble methods, you can significantly enhance the performance of your machine learning models in various tasks.